we are going to be looking at the pH of an acid and base. First of all, what is pH? Okay, pH, well, we can also call it potential hydrogen, okay, or power of hydrogen, anyone you want to call it. Okay, so pH is what we use to determine the degree of acidity or alkalinity of a substance. All right. So mathematically, pH is giving us negative log of hydrogen ion concentration. Okay. So now, this is just the mathematical definition. This is just the mathematical definition of a pH. Okay. This is just the mathematical definition of a pH. Now, for acids, pH of an acid is negative log of the concentration of that acid if that acid is a strong acid. So the concentration of this Ca is equal to the hydrogen ion, because for an acid to be strong, it must completely dissociate in water, liberating what? Hydrogen ion as the only present what? Ion. Okay? So, but for a strong base, now remember we have talked about acids, strong acids. Example of strong acid, HCl, H2SO4, and HNO3, that's sulfuric acid, nitric acid, and hydrochloric acid. These are strong acids. So when these acids dissociate in water, they will produce hydrogen ion, which is like the concentration of this hydrogen ion. Okay. So when you now find the negative log of these concentrations of the acids, you have gotten the pH. The same thing goes to base. Examples of strong base. Remember, we have bases like sodium hydroxide and potassium hydroxide and the rest of them. These are strong bases. Okay. So they are also giving us POH, which is equal to negative log of the what? Hydroxide ion. Where also this hydroxide ion will serve as the concentration of the base. Remember, the A stands for acid, okay? The B stands for what? Base. So if the concentration of this hydroxide ion is equal to the concentration of the base, we can also say that POH is equal to negative log concentration of what? B. So whenever you are solving any calculation and you are being given the concentration of the base and the base is a strong base, then that concentration should be here. Then you find the negative log of this guy. The same thing goes to the acid, okay? You find the negative log. But now, if we are talking about a weak acid, remember that weak acids do not ionize completely. So because of that, you have to introduce the ionization constant of the acid, which is Ka, and also the concentration of that acid. So the pH of a weak acid is negative log concentration of Ka times what? The Ka times what? That of the acid. You have this for weak acids. Okay? So where this Ka, remember we have talked about Ka as the ionization constant of the acid. So remember that we said that for weak acid, the hydrogen ion is equal to the square root of the Ka multiplied by Ca. So if we have pH to be equal to negative log of this, so and this is equal to this, we can just replace it with this. That's what I just did here. Then for weak base, remember how we started from strong acid. For strong acid, simple, just take the concentration, find the negative log. The concentration of the acid will act as the concentration of the hydrogen ion, okay? Then for strong base, the same thing. The hydroxide ion concentration will also serve as the concentration of the base. So just put the values here and solve. So we're going to solve problems from this. But for weak acid, you have to put into consideration the ionization constant, because this guy is not ionizing completely. So there is a constant Ka for this guy. So the Ka times the Ca is equal to the hydrogen ion concentration. So you substitute the values here, you solve. So for weak base, the same thing. For weak base, the hydroxide ion concentration is equal to the square root of the Kb, that's the ionization constant of the base, times the concentration of the word base. So we have that the POH for this guy will be minus log square root of Kb multiplied by what? Cb. So these are the equations that will help us to evaluate the pH of these acids. Remember that from the auto ionization of water, we're also able to create a relationship between pH and POH, which I gave you initially as pH plus POH is equal to 14. So this equation is an important equation that will help us evaluate the pH and the POH depending on what you are trying to solve in a particular question.